Welcome to problem 3 of the 2025 AIME 1 problem series. So, in this problem, we're given that the 9 members of a baseball team went to an ice cream parlor after their game. Each player had a single scoop cone of either chocolate, vanilla, or strawberry ice cream. So I'm going to write this down: chocolate, vanilla, or strawberry ice cream, where C represents the number of players who chose chocolate, V represents the number of players who chose vanilla, and S represents the number of players who chose strawberry. And so it basically says that the at least one player chose each flavor. Okay, and the number of players who chose chocolate was greater than the number of players who chose vanilla, which was greater than the number of players who chose strawberry. Let n be the number of different assignments of flavors to these players that meet these conditions. Find the remainder when n is divided by 1,000. Okay, and so the best way to proceed with this problem is casework. And the reason for doing casework is this condition over here. Is that the number of players who chose chocolate was greater than the number of players who chose vanilla, which was greater than the number of players who chose strawberry. And so that actually limits our cases by a lot more than if that condition was not present. And so what we can do now is just do some basic casework. And so first, well, we know that at least one player chose each flavor. And so let's consider the case where only one person or only one player, oops, only, need to switch back to my pen, where only one player chose strawberry. Well, if only one player chose strawberry, well, then the number of players who chose vanilla must be greater than the number of players who chose strawberry. So we must have at least two. So let's consider if it's two. Well, then, since there's 9 players total, and C must be greater than V, well, there has to be 6 players who chose chocolate. So the numbers horizontally must add up to 9 to resemble the 9 members of the baseball team. So, okay, well, that's great. Well, let's consider another case where the number of players who chose strawberry was 1, but 3 people chose vanilla. Well, that means that 5 players would choose chocolate. Okay, let's try another one where one player chose strawberry, 4 chose vanilla, meaning that 4 plus 1 is 5, and then there's 9 total, so 4 players chose chocolate. Well, the problem with this case is that remember that C must still be greater than V. The number of players who chose chocolate was greater than the number of players who chose vanilla, so this case actually will not work. Okay, well, so it looks like we'll have to move on to when strawberry is 2. Well, vanilla must be at least 3, and so that leaves chocolate to be 4. Okay, well, what about when strawberry is 2 again and vanilla is 4? Well, that means that chocolate must be 3, and that's actually not going to be possible because chocolate must be greater than vanilla. And when strawberry is ever greater than 2, when it's 3 for example, vanilla will have to be 4, chocolate will have to be 2, and so that this inequality will not be satisfied. And so it turns out that these are the only 3 cases that we have to deal with. So 3 cases. And so well, let's consider the first case. Well, for the first case, we know that the number of ways to assign these flavors to 9 players. We can basically use some combinatorics here. So let me pick this color. So if there's 9 players total, well, the number of ways to assign them to chocolate is going to be 9 choose 6. There's going to be 3 remaining, so you can do times 3 choose 2, or you can actually work in the backwards direction, and that's actually going to be easier for the sake of this. So the number of ways to choose a strawberry um, of the 9 players is going to be 9 choose 1, and then we have 8 choose 2. And so 9 choose 1 resembles the number of ways to choose one strawberry person, and then of the remaining 8 people, 8 choose 2 resembles the number of ways to choose the 2 vanilla people. And obviously the remaining 6 people will have to choose chocolate But 626 is obviously 1, so we don't really need to write that in. Okay, well, for the next case, we have, um, well, we can do the same thing here. 9 choose 1 ways to choose the strawberry people. Then 8 remaining people, 8 choose 3 ways to pick the vanilla. Okay, that's great. Well, for this one, we can do 9 choose 2 ways to pick the strawberry people. The remaining 7 people, it's going to be 7 choose 3 ways to pick the vanilla. And so essentially, n is the number of total assignments is the sum of each one of these. So let's go ahead and start computing. Well, 9 choose 1 is equal to 9. Um, 8 choose 2 is equal to 8 times 7 over 2, which is also equal to 28. And 28 times 9 is 252. Okay, great. So 9 choose 1 times 8 choose 3, that's going to be 9 times 56. 8 choose 3 is basically the same thing as 8 times 7 times 6. Ways to pick over 3 factorial possible arrangements. 6 is equal to 3 factorial, so those cancel, and so we're left with 8 times 7 or 56. And so this is equal to 504. And lastly, we can do this. And so 9 choose 2 is equal to 9 times 8 over 2 factorial, and that is going to give us 36. And 7 choose 3 is 7 times 6 times 5 over 3 factorial or over 6. And the 6's will cancel, and we are going to get 35. And so here, 36 times 35, we can just write that out here to the side. 36 times 35, we get 180, 1080, 1260. And so essentially, all we have to do is just add these. And so let's do purple. Or actually, let's do this. Okay. Well, 252 times, or 252 plus 504 is 756. And 756 plus 1260 is equal to 2016. And so the remainder when n is divided by 1,000 is the same thing as the remainder when 2016 is divided by 1,000. And so that is going to give us an answer of 16. Okay, thanks for watching. Have a great day.